Hey there, science fans! Welcome back to another exciting episode where we explore the wonders of mathematics. Today, we're diving into the fascinating and sometimes mysterious world of trigonometry. It's a branch of mathematics that deals with the relationships between the sides and angles of triangles. Don't worry, it's not as scary as it sounds. In fact, once you get the hang of it, you'll see how fun and useful it can be. We're going to focus on right-angled triangles, the stars of the show. These triangles are the foundation of trigonometry and are essential for understanding more complex concepts. A right-angled triangle is a special triangle with one right angle which measures 90 degrees. This unique property makes it incredibly useful in various applications. You can find these triangles everywhere, from ramps to rooftops, and even in the design of buildings and bridges. They are all around us, playing a crucial role in our daily lives. Understanding them opens up a whole new world of math and problem solving. It allows us to tackle complex problems with confidence and precision. Let's break down the parts of a right triangle because each side plays a crucial role in trigonometry. The three sides are the hypotenuse, the opposite side, and the adjacent side. This journey will lead us to sine, cosine, and tangent essential tools for understanding triangles and their secrets. These functions help us calculate unknown angles and sides, making trigonometry an indispensable part of mathematics. Imagine standing at one of the acute angles in a right triangle. You're about to embark on a journey to understand the unique names given to each side of this triangle. The sides get special names depending on your viewpoint. These names help us communicate and solve problems more effectively. The longest side, always opposite the right angle, is the hypotenuse. It's the most prominent side and plays a crucial role in trigonometry. Think of it as the big boss of the triangle, commanding attention and respect. Now, look across the triangle from where you're standing. This perspective is key to identifying the next side. That side, directly opposite you, is the opposite side. It's the side that faces you directly, making it easy to spot. It's like looking across the room at something interesting, catching your eye immediately. The remaining side, the one right next to you, is the adjacent side. It's the side that stays close, almost like a trusty companion. Knowing these names is super important because they're the key to unlocking sine, cosine, and tangent. These functions are the building blocks of trigonometry. Each of these trigonometric functions tells us about the relationships between the sides and angles in a right triangle. They help us solve real-world problems and understand the geometry around us. Get ready, because things are about to get trigonometric. With this knowledge, you'll be able to tackle complex problems and see the world in a new mathematical light. First up is sine, often shortened to sin. It's one of the fundamental trigonometric functions you'll encounter in math. Don't let the name fool you. It's not about committing a math crime. Instead, it's a handy tool for solving problems involving triangles. Sine tells us about the relationship between an angle and the opposite side of a right triangle. It's crucial for understanding how triangles work. Think of it this way: sine represents how much the opposite side is stretching compared to the hypotenuse. Imagine pulling on a rubber band. The more you pull, the more it stretches. To calculate the sine of an angle, let's call it angle A, you divide the length of the opposite side by the length of the hypotenuse. This ratio gives you the sine value. It looks like this: sin A equals sine opposite hypotenuse. This simple formula is a powerful tool in trigonometry, helping you solve various problems involving right-angled triangles. Section 4, cosine, the adjacent's influence. Next, we have cosine, often shortened to cos. Cosine is all about the adjacent side and its connection to the hypotenuse. It reveals how much the adjacent side is squished compared to the hypotenuse. Just like with sine, we use a simple formula: cos A equals adjacent over hypotenuse. Here, angle A is the same angle we used for sine. So, cosine tells us the ratio of the adjacent side's length to the hypotenuse's length in a right triangle. Section 5, tangent, a ratio of opposite to adjacent. Last but not least, we have tangent, shortened to tan. Tangent focuses on the relationship between the opposite and adjacent sides. It's like comparing how far you can reach across the room versus how far you'd walk to get there. The formula for tangent is tan A equals opposite over adjacent. Notice that the hypotenuse is not involved in this one. Tangent solely focuses on the ratio of the opposite side's length to the adjacent side's length. Section 6, Trigonometry, a foundation for exploration. Congratulations, you've just unlocked the basics of sine, cosine, and tangent. These trigonometric functions are powerful tools for understanding right triangles and solving real-world problems. Whether you're calculating the height of a building or the distance across a river, these trigonometric ratios will be your trusty sidekicks. So embrace the power of trigonometry and keep exploring the fascinating world of math.